The next topic is confidence interval for population proportion pi. So if the population has only two possible values, zeros and ones, or males and females, or smokers and non-smokers, and so on. Okay. So when you have a population that has the specific characteristics of being binomial, then the population mean is actually a proportion of successes in the population, and we call that as pi. So instead of mean mu, the equivalent of mu in this particular case, this particular special population, is pi, and we want to develop a confidence interval for that pi. Instead of for mean mu, we are now going to develop a confidence interval for pi. So because of the special characteristic of the population, population having only two possible values, the formulas are slightly different. So we have pi, and we take a sample, and in sample we compute the proportion of successes, and the notation that we use is p. So p is equivalent to x bar in the regular population. So like pi is equivalent of mu, p is the equivalent of x bar. Okay. Now sigma sub x bar we calculated in the regular case of the population. Now sigma sub p here, instead of sigma sub x bar, we have sigma sub p. The sigma sub p actually turns out to be pi times 1 minus pi over n under square root. So this is the theoretical formula. But for this theoretical formula to work, we need to know the value of pi, which is unknown. So we are kind of stuck. Okay, it is like a catch-22 situation. So only if you know the value of pi, we will have the value of sigma. And if you know the value of pi, why would you want a confidence interval? You already know the value of pi. So you won't know the value of pi in the normal circumstance. So we have to estimate the sigma sub p with, we replace pi with the sample proportion p, and then we get a standard error estimate. So then the confidence interval turns out to be this. So p plus or minus, in this case, we use normal, there is no t here. For population proportion, when we use sample proportion, the sample proportion can only follow normal distribution or not. There is no t distribution, so you need to make sure that the sample is large enough. Okay, and that is a condition for that. We will look at that in just a second. So your point estimate, okay, like in the generic format, point estimate plus your z table value, alpha over 2 is the subscript, and then standard error of p is given by this square root of p times 1 minus p over n. Now for large sample, you need to have n times p and n times 1 minus p both greater than 5. Okay, so that is if that is so, then the sample is considered large enough, okay, for p to follow normal distribution. The 30 is not used here. It's just n times p and n times 1 minus p. Here is an example. A random sample of 100 people shows 25 are left-handed. We want a confidence interval of 95% for the proportion of left-handers. So that's the formula. So p is 20, sample of 100, 25 are left-handed. So 25 over 100. For 95%, z is 1.96, and then p times 1 minus p over 100 gives you the confidence interval. Now let's work an example problem in Excel.